Your best ideas are not built at your desk. They are built while you are unconscious. Every night, your brain runs a secret workshop. It cleans itself, rewires itself, and quietly solves the problems you could not crack during the day. Scientists can now watch it happen. And once you know how it works, you can aim it. You can go to bed with a problem and wake up with the answer. Here is exactly how to trigger it. Meet Daniel. Daniel has a problem he cannot solve. He has stared at it for 9 hours. His coffee is cold. His screen is blurry. Nothing is moving. This is where most people give up. But Daniel is about to learn something strange. The harder you push a tired brain, the worse it gets. Why? Because deep sleep is a biological brainwash. When Daniel finally lies down, his brain shifts into slow-wave sleep. Brain cells shrink by up to 60%. Spinal fluid rushes in through tiny channels called the glymphatic system. It flushes out waste proteins that build up all day. One of those proteins is linked to brain fog and poor focus. During the day, you cannot clear it fast enough. Only deep sleep opens the drains. At the same time, the prefrontal cortex powers down. That is the part of the brain that judges, plans, and says no. All day, it has been shutting down wild ideas before they can form. It is a loud, careful editor. There is another reason daytime thinking fails: stress. When Daniel is anxious, his body pumps out cortisol. Cortisol is great for running from danger. It is terrible for creativity. It locks the brain into narrow, safe patterns. It tells you to repeat what already worked, even when what already worked is not working now. So here is the climax. You cannot force an insight from a brain that is full of waste, locked by cortisol and guarded by an editor. You have to let it rest first. Deep sleep is not the absence of thinking. It is the cleanup crew that makes new thinking possible. But cleanup is only step one. The real magic happens later in the night, and it has its own chemistry. So what actually builds the new idea? After deep sleep, Daniel's brain shifts into REM. His eyes dart back and forth under closed lids. His body is paralyzed, and his brain lights up like a city at night. REM sleep does something wild. It takes the day's memories and breaks them into pieces. Then it mixes those pieces with older memories from years ago. Things that never met during the day suddenly meet in the dark. A chemical called acetylcholine floods the brain during REM. Acetylcholine helps neurons form new connections. At the same time, another chemical, norepinephrine, drops to almost zero. Norepinephrine is the alarm signal. Without it, the brain feels safe enough to try strange combinations it would never try awake. There is one more trick. During REM, your senses shut down. You cannot hear the room. You cannot feel the bed. With the outside world gone, the brain is free to run full simulations inside itself. It tests scenarios. It plays out conversations. It rehearses problems from new angles. This is why a problem that looked flat at midnight can look three-dimensional by morning. Daniel's brain is not just resting. It is running thousands of tiny experiments he will never remember. So here is the climax of this section. REM is not a dream factory for fun. It is a connection engine. It is where insight is actually built, atom by atom, while you lie still. But the engine needs fuel, and the fuel is something you choose on purpose in the 20 minutes before you fall asleep. So what should Daniel do before bed? This is where most people destroy their own breakthrough without knowing it. The brain takes whatever you feed it last and chews on it longest. Researchers call this a cognitive anchor. The thoughts you hold in the final 20 minutes before sleep get priority access to the night shift. If Daniel scrolls his phone, his anchor becomes random outrage, gossip, and short videos. His brain spends the night sorting noise. The blue light from the screen also delays melatonin, the hormone that starts deep sleep. He loses cleanup time and connection time at once. Worse, every swipe gives him a tiny hit of dopamine. Dopamine is the chemical of wanting more. It keeps the brain in seeking mode. Seeking mode is the opposite of solving mode. You cannot incubate an answer while you are still hunting for the next swipe. So Daniel does the opposite. He puts the phone in another room, he dims the lights, he takes a single problem, the one that mattered most that day, and he frames it as a clear question. Not a vague worry, a real question with a stake. Instead of, "I am stuck on this project," he asks, "What is the one thing my user actually wants that I am ignoring?" The sharper the question, the better the night shift can work on it. Here's the climax. The pre-sleep seed is not relaxation. It is a deliberate handoff. You are giving your sleeping brain a job order. Whatever you hand it, it will work on, so choose carefully. But framing the question is only half the protocol. The other half is how you plant it. So how does Daniel actually plant the seed? There is a simple technique called sleep incubation. Scientists have studied it for decades, and it works. Step 1 is micro-journaling. Daniel takes a small notebook. He writes the problem down in 2 or 3 sentences. Not a full essay, just enough to make it real outside his head. Writing forces the brain to commit. A vague worry stays vague. A written problem becomes a target. Step 2 is spatial visualization. Daniel closes his eyes and pictures the problem as a physical object or place. Maybe his project is a building with a missing floor. Maybe his conflict is 2 roads that need to meet. The brain remembers space far better than words. Giving the problem a shape makes it easier for sleep to grab. Step 3 is intention. Right before he drifts off, Daniel says one quiet sentence to himself. "Tonight my mind will work on this. In the morning, I will know more than I know now." This is not magic, it is a signal. The brain takes intentions seriously, especially the last one of the day. Then he does the hardest part. He lets go. He does not try to solve it. Trying keeps the prefrontal cortex online, and the editor must go offline for the workshop to open. Here is the climax. Incubation is not wishing. It is a precise 3-step handoff. Write it, picture it, set the intention, then release it. Do all 3, and your sleeping brain treats the problem as priority work. But none of it matters if Daniel wastes the most fragile moment of the whole cycle, the morning. So what happens when Daniel wakes up? There is a window, and it is short. The first 90 seconds. When he first opens his eyes, his brain is in a state called the hypnopompic state. It is halfway between dreaming and waking. The connections built overnight are still floating near the surface. Acetylcholine is still high. The editor has not booted up yet. This is the golden window. Insights from the night shift are most reachable here, but they fade fast. Within a few minutes, normal waking chemistry returns, and the bridge to those new connections starts to crumble. This is why the phone is the enemy. The second Daniel grabs his phone, dopamine spikes. Notifications flood his attention. The hypnopompic state collapses. Whatever his brain solved overnight gets buried under emails before it can surface. So Daniel keeps the notebook by the bed. The moment his eyes open, before he moves much, he writes. Anything. Fragments, half sentences, a weird image, a name. He does not judge it. Judging is the editor. The editor stays asleep a little longer. Most mornings, what he writes looks useless, but once or twice a week, a sentence appears that he did not plan. A connection, a new angle, the answer to the question he planted the night before. He keeps these notes in one place. Over weeks, a feedback loop forms. He sees which kinds of questions get answered and which do not. He sharpens his seeds. The protocol gets stronger every cycle. Here is the climax. Your brain solves problems while you sleep because deep sleep clears the waste, REM builds the connections, the pre-sleep seed gives it a target, and the morning window lets you catch what it built. You do not have to be smarter. You just have to stop interrupting the workshop. Plant the question, drop the phone, pick up the pen. Daniel did. And the problem that beat him for 9 hours was solved before breakfast.